Ideas, Algebra 1, Chapter 6, and we have Section 6.2, which is dealing with exponents. So in exercises 1 and 2, it says find the indicated real nth root of A. So we know that n is the root, so it says, so what we're doing is we're sort of saying, hey, if this is n and this is a, so we'll just replace those. So it's the sixth root of 64. So can I write 64? Because what's going to get rid of a sixth root? A sixth power. So can I break 64 down to equal some value to the sixth power? Well, 64, let's do the prime factorization, is 32. 32 is 2 and 16. 16 is 2 and 8. 8 is 2 and 4. And 4 is 2 and 2. So we have 1, 2, 3, 4, 5, 6. So 64 can be written as 2 to the 6th. So I have 2 to the 6th. And now what gets rid of a sixth root is a sixth power. They cancel, and you're left with 2. Now, we do plus or minus 2 because a negative 2 to the sixth power would produce positive 64. Any even number, or any number to an even power, we would need to introduce the positive and negative root, value. So this says the fifth root of 243. So we again are going to break this into its prime factors. So I'm going to divide it by 3. That's a logical one, gives us 81. 3 is going to give us 27. 3 is going to give us 9. And 3 is going to give us 3 and 3. So we can write 243. We can write 243 as 3 to the 5th, and we know that those fifths will cancel, so we know that it is positive 3 this time. Because a negative would produce a negative, so it wouldn't cancel out. The negative here, plus or minus 2, if we had a negative, there's an even number of negatives, so it would cancel to be positive. So all negatives would end up being positive. With a negative, with an odd root, with an odd power, that negative stays, so it doesn't cancel. So volume equals big B times H. It's a cube, so the base shape is length times width times height. So that equals S times S times S, or S cubed. And we know that the volume of a cube is always going to be S cubed. So if the volume equals 729, so what's going to get rid of a cube is a cube root. So we'll take the cube root to get that. Since it's odd, we know, and it's distance. So those will cancel, and then we want to look at 729, and we want to break it up. So I'm going to break that into 9, and that gives me 81. Well, I'm not going to break 9 down to 3 and 3, because I want powers of 3, or to the third power. I want a base to the third. So we know that 729 can be written as 9 cubed. Those cancel, and you're left with 9 equals S. We look at the unit as centimeters cubed, so we know that a side length is going to equal 9 centimeters. Same thing, we can just jump to, we know that volume is going to equal side cubed. Side is 1,000. So we're going to take the cube root of both sides. We get S because they'll cancel. Can we write 1,000? Yeah, 1,000 is, everybody should know that. I mean, you should know this. You should know that 10 to the third equals 1,000. So the cube root of 10 to the third, so 10 equals a side length, it's yards. So a side is 10 yards. Each side is 10 yards. All right. Okay. So we can have that. So what number times itself 3 times is going to produce negative 512? So I don't know, 6? I kind of want to say 6. That's going to go, what goes into 40? 6 times 8 is 48. With 3, 32, 84. 6 goes into 84. That's not going to be 3 times. Well, let's do this. Let's show the other way we can do this. Let's do this. So 2 times 3, 84. Let's do 4 and 21. We can go 2 and 2. We can go 3 and 7. Hiya. All right. Well, I don't know where that 7 came from. Let's make sure that 84 times 6. 84 times 6. 504. So I made a mistake. Clearly I made a mistake because it didn't come out right. Sorry. Now, we could use technology. No, let's do 512. Let's do the prime factorizations. So let's do 2. Let's keep it simple, kids. 256. Let's do 2. And that's 148. Let's do 2. And that's 74. Let's do 2. I don't know if this is going to work. 2 is going to be 37. Oh, I did it wrong again. What is wrong with me? 2, 5, 6. That's correct. 1. Oh, that's 128. Sorry. 28. Mr. Mac. That's going to be 64. That's going to be 32. Oh my gosh, this is going to be some power of... Okay, 32 is 2 and 16, and 16 is 2 and 8 is 2 and 4 is 2 and 2. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 of these. Now I want to produce 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to get it in groups of 3. So that's 3, and that's 3. So that's 8 to the third. So I can write that as negative 8 to the third. These are going to cancel, and you're left with the opposite of negative 8. So it's positive 8. Whew, that was very long. Now, hey, we can do 5, 1, 2, and do the cube root, and we would have found 8. But I just wanted you to see how prime factorization can still help you. All right, this is in exponential notation, and we need to convert it to root rotation or radical notation. So the numerator is going to be the power, and the denominator is going to be the root. Now, 729. Let me show you 729. 729 to the 6th root equals 3. Now, I don't know how anybody would have seen that, but that equals 3. Here's the other way we can do that, is we can write 729. Let's do the power. So we have 7, 8, 9. So 9 goes into that. 9 goes into this 81 times, and 9 goes into that and that. Now that doesn't give us 6, that's 9 to the third, so that didn't help us very much. But, we're in exponential. Let's do this. So I'm showing you 729. 729. Let's do this. 729 to the 1/6, right? 1/6. And we can write that as 9 to the third to the 1/6. And remember, power of a power, we're going to multiply. So we have 3 times 1/6, which equals 9 to the 1/2. And now we can do 9 as 3 squared to the 1/2, which is 3 to the 2 times 1/2, which equals 3 to the 1, which equals 3. Hey, ho! Yes, we got it! That was cool. Hopefully you saw that. So we have the fourth root of negative 625. What you should automatically know, moving any further, is can't have an even root of a negative number. If it was an odd root, we can do that because odd roots can produce negatives. Evens will cancel their negatives. Sorry, I'm about to... Excuse me. Rewrite the expression in rational exponential form. Okay, so this is the quantity of negative 53 to the 4/5. Is that all we had to do? Yeah. So remember, the power goes in the numerator and the root goes in the denominator. So I call that exponent form. Oh yeah, exponent form. So this will be 110 to the 7/4. That's super easy. We like that. This is the quantity of negative 34. Oh, now let's do the other way. So we are going to do the quantity of negative 34 to the 4th. And the 9th root, we need the parentheses around there. So that would be our answer. Here is 41 to the 7th and the 4th root. Again, denominator is our root, numerator is our power. We have the 7th root of the quantity of negative 128 to the 3rd power. And now we have to simplify this. Well, I don't know if I'd do it in that power. Sure. 128. Well, let's look at 128. So I like 4. 4 goes into 32 times. 2, 2. Wow. I didn't know 128 was a power of 2. 2, 16, 2 and 8, 2 and 4, 2 and 2. And that gives us 1, 2, 3, 4, 5, 6, 7. 7. So that would be negative 2 to the 7th. Yeah. To the 3rd. So that's going to be the 7th root of negative 2 to the 7 times 3, which is 7 to the negative 2 to the 21st. And now I'm going to rewrite it in exponent form, which is 21 over 7, which is negative 2 to the 3rd, which equals negative 8. Oh, baby. That is there are lots of different ways to do this. So I like this one. At least I can see that. That's negative 5 squared to the 5/2. And now I'm going to have a power of a power. And those cancel. So I get negative 5 to the 5th, which is negative, really big number. 5 to the 5th equals 3125. 3125. Why didn't I get that? Why did that not? 13, not a real number. Whoops. That does not equal that. Mr. Mac made a mistake. Sorry. So we would have seen it, and I would have seen it if I wrote it as an exponent. So that's negative 25 to the 5th to the root. This number is always going to be negative because it has an odd power. So we would end up with a negative number, and we can't take the square root of a negative number. So no solution. Or they say not a number. Not a real number. Yeah, oh right, it's imaginary because it's negative. So if we do, nope, let's do, yeah, 25. Let's do 25 negative, and let's take the square root, not a number. Yep, not, so we'll write not a number. It's an imaginary number. So I'm going to write 10 to the third because I already know that that is that. And then I get 10 to the 3 times 4 thirds, which equals 10 to the 4th, which equals 10 with 4 zeros, which equals 10,000. Nice, easy. I'm going to write 1 over, that's 5 to the 3rd, so I should start knowing these. And 1 to the 2 thirds over 5 to the 3 times 2 thirds. And 1 to the 2 thirds is equal to 1, because you square it and take the cube root. It's still going to be 1. And this is going to be 5 squared, and we get 1 over 25. 343, I should know 343. I don't know it. But 11. 343, that's 11. No, what's that? 70. 343 divided by 11. No, not 11. 343 cube root? 7. 7, 49, 7, 7. So that's going to be 7 to the 3rd to the negative 1/3. Woo! Okay, now let's deal with that negative exponent. All that does is you take the reciprocal, it puts it in the denominator. So you have 1 over 7 to the 3rd times 1/3, which equals 1 over 7. Oh, I like that. That was a little tricky. That's good. So here we have 1 over 2 to the, let's do 8 squared. We could to the 3 halves. So, no, just keep it. I was going to do negative. 1 to the 3 halves, we're distributing it out. 8 to the 2 times 3 halves, which equals 1 over 8 to the 3rd, which is a really big number. 1 over 512. The radius of a sphere is given by the equation r equals 3v blah blah, where v is the volume of the sphere, find the radius to the nearest. Now they know that volume equals 4/3 pi r cubed, and they just solved for r. So that's how they got that value. If we isolated r, if we multiply by 3/4, divide by pi, and then take the cube root, we literally get that. That is the formula, which is kind of cool. So find the radius to the nearest sphere that has a volume of cubic meters used 3.14. So, all right, we'll start plugging stuff in. R equals 3 times the volume, which is 268, over 4 times 3.14 to the 1/3 power. 3 times 268, 3 is 24, 18, 20, 804, I think. And that's going to be 16, 5, 1256. Let's make sure our math is correct. 3 times 268 gives us 804. 3.14 times 4 gives us 1256. So 804 divided by 12.56 gives us a nice number? No, not very nice at all. What are we doing? Okay, and then to the 1/3 power. So we can do to the x, no. Oh, to the cube root, sorry. Cube root, which is 4, nearest centimeter, to the 1/3. So that gave me something like 64-ish. What was it? 64.01, blah, 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 to the 1/3, which is the cube root of 64, which gives us approximately 4, what do we want, centimeters. Yep, we'll take that. To calculate the annual inflation rate, R, in decimal form of an item that increases in the value of P to F over a period of n years, you can use the formula R equals the annual inflation nearest step of the percent of coin increase value from over a period of 30 years. F from P to F. From P to F, so this is P, this is F, so 1.5 over 0.25 to the 1/30 minus 1. I don't know if you saw the minus 1 there. So R equals, how many quarters are in $1.50 is going to be 6 to the 1/30th? Wow, minus 1. Why do I feel like that's not correct? Maybe. Yeah, okay, let's do 6 to the 1/30th. That's the 30th root of 6. That seems a little extreme. We're going to use y root of x. So we'll do, let's clear it, not 3, Mr. Mac, 6 to the 30th root. Oh, that's actually not so bad. 1.06. 1 R equals 1.06 minus 1. So the rate equals 0.06 or 6%. Oh, so I think it says 1/10 of the percent. So we're going to have to go out to 1.5. So if we're going to, right, because percent, 1/10 of the percent, that's our 1/10. We would move our decimal 1, 2 places to make it a percent. So 6 point, and that's going to be 2 because we're going to round up. That's it. Yeah. I don't, that's pretty advanced stuff. I don't know how much we're going to use on the assessment, but it's good stuff. It's just really, really advanced and very niche. That we would call that a niche section. Save as.